Hello, and welcome back. In the previous video, we looked at how to build a package out of the directories and files. In this video, we're going to look at adding actual code to the package and add a couple of pitfalls to avoid. Python modules have the same name as objects that they have as file names, except without the .py suffix. That means that the file names need to be valid Python variable names, and also that they should use letters and symbols that are reliably available across different operating systems. So, as examples, module names should not start with a number because Python variables are not allowed to start with numbers, and should not use capital letters because some common operating systems don't differentiate between file names containing capital letters and file names that are all lowercase. As long as we stay within those guidelines and remember to use a .py suffix, we can name our modules anything we please. So, we just pick a file name and start writing Python code into a file with that name in the package folder. That simple scenario is also the common case, but there's another possibility. As we've mentioned before, starting in Python 3.3, it's possible to have a package folder that doesn't contain an init file. Leaving out the init file means we can't support import star or the other tricks within it that we'll discover as we go along. But there's more to it than that. When the init file is missing, the folder becomes part of a namespace package. When Python is importing, it combines all of the namespace package folders it finds that share a name into a single logical package. That behavior means that while choosing the module file name still follows the same rules, we could potentially place that file into one of any number of namespace package folders instead of into a singular concrete package folder. What do we gain from that? Often nothing. As I mentioned before, packages with an init load faster, and in many cases, the extra abstraction of namespace packages doesn't buy us anything. There are cases, however, when we want different parts of the same package to be distributed or managed separately, and when we do, namespace packages address that need. For example, imagine again that we're working on a package for playing soundtracks. If we make a namespace package for audio codecs, each codec can be installed and removed individually using pip, or the operating system's normal package management tools. On a slightly different topic, now let's talk about the difference between how a package is structured and the interface it should present for use by external code. For the convenience and sanity of ourselves, as the package developers, it's often best to break up the code in a package into many different modules that each contain a selection of conceptually related code. That is the package's structure. And as a rule of thumb, whenever we think we might want to break the code up into more modules, we probably should go with that impulse. On the other hand, external code calling on our package is best off when it can take advantage of our code with just one or two import statements that bring in a small number of functions or classes. That is the package's interface, and as a rule of thumb, it should be as minimal as possible while preserving full functionality. Fortunately, we can have our cake and eat it too. We can divide our code up however we wish and then import the most useful elements into our init file, which will make them part of the package's root namespace. If all that's in init file is import statements, we don't need all variable. An import star will grab the contents of the init file, except for variables, starting with an underscore. However, if we define or import anything in the init file that should not be part of the public interface, we can use the all variable to narrow down and control what we export. Just remember, if we have an all list, it needs to list everything that is part of the package's interface, whether a module, class, function, or variable. The rest of the modules in the package are still available to be explicitly imported. We're just making it convenient to access the parts that are most likely to be useful outside our own package. Now we have a good idea of how to name our modules, where to put them so that they become part of our package, and how to give our package a convenient interface. In the next video, we'll move on to looking at how to make the modules in a package interact with each other.